because it's the most sensitive spectroscope that we have ever flown in space. Spectroscopes, or spectrographs, are so important for research. They produce ugly pictures. But they are the nuts and bolts of physical science. They put the physics in astrophysics. COS was conceived in the mid-1990s by Dr. Jim Green and his colleagues at the University of Colorado, primarily to study the cosmic web, which is made up of the largest scale structures of matter in the entire universe. If you want to know what something is made of, how hot it is, how dense it is, how fast it's moving in space, how fast it's rotating, for example, a spectrograph will give you all that information. With COS, we can acquire information like that farther out across the universe than we've ever been able to do before.
Spectroscopy is taking light from an object and breaking it up into the different colors that that light consists of. Each of the elements, each of the chemical elements has characteristic wavelengths, characteristic colors at which it emits light when you heat it up or absorbs light. For example, if I have a tube full of hydrogen between me and that light, instead of seeing the normal spectrum of that light when I look at it with the spectrograph, I'll see that spectrum, but with some of the light taken away at the wavelengths where hydrogen has its characteristic absorptions. And so by measuring the depth of those notches and the velocities and the width of them and so on, you can infer all kinds of things about the physical state of that cloud. COS has taken a really key part of spectroscopic science and said, how can we do that in the absolutely best, most efficient way? And that is to measure the properties of the material between the galaxies, looking back into the universe. As the galaxies form, there's a lot of material that does not collapse into the galaxies, and there's other material that is ejected from galaxies by supernova explosions and so on. And so that intergalactic gas, the so-called intergalactic medium, carries a lot of information about the history of the universe.
When you couple that story, sort of the global cosmic process of how you form the large-scale structure of how material is distributed in the universe and what role that played in forming new galaxies, and then you use Wide-Field Camera 3 to investigate how did the galaxies themselves change internally with time and over space, looking back through the history of the universe. All that kind of ties together into the full story of where we came from.
It's going into the CoStar slot, and so there is nothing whatsoever lost in doing that because CoStar is not needed anymore. CoStar was put up in the first servicing mission, and it was used to deploy correcting optics in front of some of the first generation instruments, the first generation spectrographs, for example, correcting optics to correct for the spherical aberration that had been inadvertently built into the HST primary mirror. All the more recent instruments include that correction within the new instrument itself. So right now, CoStar doesn't have anything to do. All the other instruments in the so-called axial bays of HST have their own internal correction, and so the CoStar space is freely available, and they'll pull that out at no loss of science to HST whatsoever and replace it with this terrific new spectrograph.